Welcome to the deep dive. Today we're plunging into, well, one of the oldest and maybe most profound mysteries there is. What actually happens when we die? A point where they were clinically dead or very, very close.
Precisely. And the things people report often have these striking common threads, don't they?
Yeah, like that feeling of being outside your own body,
Yeah,
looking down.
that's a classic one. Or seeing an intense, often described as welcoming, bright light. And then there's the life review, that incredibly rapid playback of memories.
The whole life flashing before your eyes.
Exactly. And the interesting thing is, these aren't just, random anecdotes. You see similar reports across different cultures, different eras.
Okay, right. So let's dig into the science. The first big piece we have here is a study published back in February 2022. And the challenge here, scientifically speaking, is huge, isn't it?
Oh, immense. I mean, you obviously can't just take healthy people, hook them up to brain scanners, and wait for them to die. Ethically impossible, and practically too.
Death isn't exactly predictable.
Not usually, no. So this first study, it happened almost by accident. It was really serendipitous.
Oh.
Well, scientists were already monitoring an 87-year-old man with an EEG, that's the machine that records brain waves. He'd had a fall, wasn't doing well.
Okay, so routine monitoring.
Routine monitoring. And then while he was hooked up, he suddenly had a heart attack and, well, he passed away.
Wow. So they captured it because it happened unexpectedly during the monitoring. The sources mentioned this wasn't the very first recording ever, but others were limited.
That's right. There had been some kind of limited recordings before, often maybe just from the front of the brain, sometimes when life support was being withdrawn. But this was different.
How was it different?
It was the first detailed recording across pretty much the whole brain, right at this critical moment. They had about 15 minutes of data overall, but they zeroed in on the really key period.
Which was?
The 30 seconds before his heart stopped, and crucially, the 30 seconds after the heart stopped beating.
And this is where it gets really mind-bending, right? What did they find after the cardiac arrest?
Yeah, this is the astonishing part. You'd think, logically, brain activity would just cease,
Right.
flatline.
Right. Lights out.
But it didn't. Not immediately. They saw these very distinct, quite complex patterns emerging in the brainwaves. Patterns that you normally see with high-level cognitive functions.
High level. Like what?
Things like processing information, focusing attention, retrieving memories, conscious perception. Even patterns similar to what we see in different stages of dreaming.
Seriously. Dreaming.
Yeah.
Memory retrieval. After the heart stopped.
That's what the pattern suggested. The researchers looked at this data and, well, their interpretation was that it possibly indicated the brain was actively recalling memories.
Actively recalling memories at the point of death.
Okay.
They talked about specific brain waves, didn't they? Alpha and gamma.
Yes, exactly. Alpha waves are, generally slower, associated with being alert but calm, maybe learning. Gamma waves are the fastest ones. They're really strongly linked to high-level cognition, focus, memory formation, consciousness itself.
The binding waves, some call them, bringing information together.
That's a good way to put it. And the really key finding here was something technical called cross-coupling between these alpha and gamma waves.
Okay, cross-coupling. What does that mean in simple terms?
Well, the important thing is, in healthy living people, seeing this specific kind of interaction, this cross-coupling, is a known marker for memory recall. Like when your brain is accessing stored information or you're having a flashback.
Right, so if that pattern means memory recall in us right now.
Finding it in the brain moments after the heart stopped beating led the research team to theorize. They suggested this patient could have been experiencing a recall of life.
Life flashing before their eyes.
Potentially, yes. It offered a possible biological mechanism, a brain-based reason, for that very common report in NDEs.
Wow. So this one accidental recording gave us the first scientific hint that this subjective experience might actually have a physical correlate in the dying brain.
It certainly raises that possibility very strongly. And if we bring in Dr. Sam Parnia's view, he's a major researcher in this area, looking at consciousness and death, he found this incredibly interesting, especially because this complex activity seems to pop up as the brain is shutting down.
And he connects it to those broader reports of lucidity, right?
Yes, he talks about paradoxical lucidity and heightened consciousness near death, and he emphasizes these aren't just, one-off strange stories. Surveys suggest maybe 10% of people who survive a near-death event report something like this.
10%?
Yeah.
That's huge. Hundreds of millions of people worldwide.
A vast number. So Dr. Parnia suggests this study, even though it's just one patient, raises the possibility that a marker of lucidity at the end of life may have been discovered. It hints these experiences might be real, biologically grounded events.
Okay, but we absolutely have to pump the brakes a bit on this first study, right? The researchers themselves highlighted major limitations.
Crucially important, yes. This wasn't a healthy brain to start with. The patient had significant prior injuries. There was bleeding, swelling in the brain. He'd also suffered seizures.
And was on anti-seizure medication.
Correct. All of which could seriously affect the EEG readings. It muddies the water, you know. You don't have a clean comparison. And critically, there was no healthy baseline scan from this specific patient before the crisis to compare the dying brain activity against.
So a groundbreaking clue, definitely, but not definitive proof because of the patient's specific condition.
Exactly. A tantalizing piece of the puzzle, but just one piece. Which is why the next study we're looking at from May 2023 is so significant. It comes at it from a slightly different angle.
This one was from the University of Michigan.
That's right. A different team, different circumstances. They studied 2 patients who were comatose and sadly died after cardiac arrest.
And when did they observe the brain activity in this case?
The key observations here were made after these patients were removed from ventilator support.
Okay, another critical end-of-life moment. And what was their main finding? Did they see something similar?
They also saw a remarkable burst of brain activity, specifically a really significant spike in gamma wave activity. They noted a little bump in heart rate alongside it, too.
Gamma waves again, those fast ones linked to consciousness.
Exactly the same ones highlighted in the first study. So now we have 2 independent studies, different setups, both pointing to this surge in high-frequency consciousness-associated brain waves around the time clinical death is determined.
That feels significant, like less likely to be just a fluke.
It certainly strengthens the case, but the Michigan team found something else really interesting, too. They pinpointed where in the brain this gamma surge was most intense.
Oh, they located it.
Yes, they found it concentrated in a specific area they termed a hot zone.
A hot zone. Okay, where's that located?
It's sort of nestled deep in the back of the brain, at the junction between the temporal, parietal, and occipital lobes.
And why is that location important? Does that area do anything specific?
It absolutely does. This particular junction, this hot zone, is already known from other research to be involved in things like dreaming, processing visual information, and importantly, altered states of consciousness.
Whoa. Okay, hang on. So they saw a surge in the consciousness brainwaves,
The gamma waves, yes.
specifically lighting up in the part of the brain linked to dreaming and altered states.
Exactly.
Right as these patients were passing away after life support removal.
That's the finding. The authors are, appropriately cautious. They state clearly we don't fully understand the mechanisms yet, but they say the data demonstrate that the dying brain can still be active.
It's not just flicking off like a switch.
Apparently not, and they go a step further. They suggest that based on this activity, particularly where it's happening, we can't dismiss the possibility of what they call covert consciousness.
Covert consciousness.
Meaning sort of an internal subjective awareness that might still be occurring even when the person appears completely unresponsive externally.
Like something is still happening inside.
Potentially. And they explicitly link this. They suggest this covert consciousness, driven by this gamma activity in that hot zone, could be the mechanism that allows for those experiences people report in NDEs, like the life review or other profound subjective states.
Okay, so let's try and weave these 2 studies together. We have the 2022 study, that single case, showing complex alpha-gamma coupling, possibly linked to memory recall after cardiac arrest.
Right, despite the limitations of that specific case.
And then the 2023 study with 2 patients showing a big gamma wave surge, specifically in that dreaming altered states hot zone after ventilator removal.
Both finding significant, complex brain activity, particularly involving those fast gamma waves, around these critical end-of-life moments.
It really feels like these studies provide the first concrete scientific hints that align with all those subjective reports, doesn't it? It moves NDEs and end-of-life lucidity a bit beyond just anecdote.
I think that's fair to say. It offers potential biological correlates. And Dr. Parnia, again, offers a potential theory for why this might be happening. Why would the brain suddenly become so active as it's dying?
Okay, what's his idea?
He talks about disinhibition. The idea is, as the brain is shutting down, as it's being starved of oxygen and fuel, the normal control mechanisms start to break down.
The usual filters and suppressors.
Exactly. Our everyday brain activity keeps a lot of things in check. suppresses certain functions or states. Parnia suggests that as these controls fail, as they become disinhibited, other parts or processes might emerge.
Emerge from where? Like deeper levels.
Potentially. Functions or states of consciousness that are normally suppressed or inaccessible during our normal waking life might suddenly become accessible as the standard operating system falters.
So the brain breaking down might actually unlock something.
That's the provocative implication of his theory. He suggests this disinhibition could grant access to aspects of reality at death that we would ordinarily not have access to. It might open a door to deeper layers of our own consciousness, or perhaps even perceive things differently.
Aspects of reality.
Yeah.
That's a really striking phrase. It hints at something more than just memory replay.
It does. It edges towards the truly profound questions about what consciousness is and how it relates to the physical brain, especially at the limits of life.
But, and it's a big tool, studying this is still incredibly difficult. The sources are clear on the challenges ahead.
Absolutely. As we said, you can't ethically set up the ideal experiment with healthy subjects anticipating death. It's just not possible.
So the data we have, like the 87-year-old with brain injuries or the
Right.
comatose ICU patients, it comes from inherently messy, real-world, acute medical situations.
Precisely. These patients have pathologies. They're often on medications. It's a crisis environment. It's not a clean laboratory setting,
Yeah.
which makes interpreting the data really challenging.
So what's the path forward for researchers? How do they get closer to understanding what's really going on?
Well, the Michigan study authors point towards a crucial next step. They argue we need more studies focusing on patients in the ICU who experience cardiac arrest but survive.
Because then you can actually talk to them afterwards.
Exactly. That's the missing link right now. If you can record that gamma surge, that hot zone activity during the crisis, and then the patient recovers and can tell you, yes, I experienced my life flashing before my eyes, or I saw a bright light, then you can start to directly correlate the brain activity with the subjective conscious experience.
You connect the brain waves to what the person actually saw or felt.
That's the key. Without that correlation, the brain scans are fascinating, suggestive, but what they mean in terms of subjective experience is still ultimately an interpretation. We need the first-hand reports linked to the objective data.
Okay, so let's try and wrap up the key takeaways from this deep dive. We've seen these really remarkable recent studies
Groundbreaking, really, offering unprecedented scientific data.
suggesting the brain doesn't just switch off. It can remain surprisingly active, showing these complex patterns. Things linked to memory, to high-level thought.
And specifically, those fast gamma waves, potentially concentrated in that hot zone area associated with dreaming and altered states, appearing even after the heart has stopped or life support is removed.
And these findings, while preliminary and based on complex cases, they do offer potential biological explanations, or at least correlates, for those widely reported NDEs. The life review, the feeling of lucidity.
It starts to build a bridge, doesn't it, between the subjective experiences millions report and observable processes happening in the brain. It moves the discussion forward.
Definitely. But it's also clear that the full picture, what really happens to consciousness at the moment of death, that remains one of the biggest, most profound mysteries we face. We've got clues, hints, but not the whole answer.
Not by a long shot. We're just scratching the surface, peering into the twilight.
So we'll leave you with this final thought to ponder. If these studies are hinting that the dying brain might, through processes like disinhibition, access aspects of reality, or a form of covert consciousness that we don't normally experience.
What does that truly suggest about the nature of consciousness itself? Is it purely a product of the functioning brain as we know it, or could there be more to it? What else might lie just beyond the veil of our ordinary perception?